operators of computer algebra, Mathcad and EXCEL programs used for operations on matrices and vectors. This article number 4.2 of the book Mechanical Systems Calculations of the Marine Facilities. To do the operations over the matrices and vectors, to decide the issues of mechanics, to find the efforts, forces, moments, and maybe the other elements like the stresses, strains, and displacement of the elements of the mechanical system, we have to decide the systems of the mathematical equations in the frameworks of the elasticity. Considering the linear equations, we have to use the equations of the algebra, and to decide these equations, we have to have the methods for the big dimensions of the issues, maybe for the systems of the equations more than 3, maybe more than 4. This is difficult to do the calculations. So to do that, we have to consider the used softwares. The very efficient is the computer algebra Mathcad did by the Parametric Technology Corporation, available to distribute to have, and some university distributes this Mathcad computer algebra system. If like actually like a providers of this computer algebra system, or you can apply to another one provider like Apple Store, or maybe directly to the company Parametric Technology Corporation. We can use Excel as for me more convenient to use a Mathcad. So the let's see the use of the Mathcad computer algebra system first. Okay, this is open file of the Mathcad. We have definite information here, but they just only to nothing mean. This nothing mean we will not in the definite one lesson consider the finite element methods, truss calculation. We will not do that. This is just a comment, just to explain that it's possible to do the comments here. For example, we can do another comment. For example, what is a lesson of the Mathcad, for example. Yeah, something like that. And little some words for the people who is expert, very familiar with the Mathcad. Perhaps this lesson is not relevant for these people, but this is only just for everybody, because I want to show what options of the Mathcad, or maybe in Excel, not today Excel, about this. I will say about the Mathcad. About Excel, I will talk a little bit, but with not the explanation, with not the performance of the use of the Excel. This is obvious. A lot of people use Excel in any of the issues. So we can dial here the comment lesson on the Mathcad. Oh, it was a comment here. We have here the indicated the we assigned. This is assignment like columns and the sign of the equality mean the assignment. Assignment, we designate what is M. We designate that the M is a matrix of 2 columns and 3 rows. Matrix C is a transposed matrix of M. Yes, C is symmetric to matrix M. Yes, transpose sign of this. How to do that? How to assign the matrices? Okay. First of all, let me please explain that this assignment of matrices and this is equality, is not the same. So first we have to assign. What does it mean? On the next, after the just only sign of the equality, we can watch what is the result of the operation. This is assigned the operation of transposition of the matrix M. This what is the result of the operation. The result of the operation is the matrix C. The result of the operation is here. So first of all, let's consider the panel of the Mathcad. The panel here have the sign mathematics, for example, the operators. Operators here we have this, the panel of the operator. Symbols, we can use the Greek alphabet. The definite programming, we can do the cyclical algorithm, non-linear as well. Definite constant like pi constant, other constants, E constant, Euler constant, Pythagorean constant. We can have the symbol operations as well here. It's not for today. We just consider just core approach for that. And besides, we have the units of the dimensions. Yes, like time dimension, day, yes, second, etc. Second, year, the units of time, units of the length, etc. Angstrom, etc. Inches, meters, kilometer, etc. So we can assign the dimensions, etc. So very important for us is the panel of matrices. The matrices panel here. For example, how to use the panel of the matrix. How to assign the matrix. Maybe matrix, we can say what any letter, upper size or uppercase letter or lowercase. Let's consider the uppercase matrix as indicated by H. H. Next, we have to assign. Assignment is a two buttons on the computer. Is this one shift and columns. This is assignment. Besides of that, we can do the assignment by the another way. We can use the math operators, and here we have as well the assignment. Shift and the same as the dialing of shift and the columns. And we here indicate that the H matrix is M. So we assign that that matrix H equal to matrix M. Matrix M is assigned below. All assignments have to be on the upper level and on the left on the operator's execution operator's execution. So here we can find what is the matrix H. H equal, this is matrix M. We assign the same matrix. Next we can find the total of two matrices, for example. This is below and up. If we will do that, we can select by mouse. We can move this operator, for example, here, and we have, oh, sorry, it not moves. This is the space of the comments, maybe because of that. Oh, here. Here we have nothing. Why? Because we assigned the matrix H in the next. We cannot define what is the magnitude of the element of matrix before the assigning. Before mean that above or on the left. So we have to consider it below. We do below. Yeah, below this works. So the total of the matrices, for example, H, the matrix H plus M, what is equal to the total two matrices H plus M. Okay, let's consider a definite matrix here, like matrix could be O. O matrix. No, not low. Nice. O could be matrix P. Shift columns. I assigned the matrix. I go to the panel of matrices and I assign the two-dimensional matrix. This is two-dimensional matrix. Next, I have here assigned just the magnitudes. For example, A, B, C, D. For example, I can assign H, A, B. Excuse me, I can assign here just a letter A. Oh, stop again. Again, assign the matrix 2 by 2. And the first element is A, second B, second C, second D. Okay, what is P equal to? P equal to equals, yes, and these elements are within the matrix. So what we can do else? For example, we can find the transposed matrix as we can dial P. P, this is, we indicate like transposition of matrix operations with the matrices. The transposition, maybe this is transposed. Excuse me. Another matrix, like we can say matrix Z. Z assigned the P, assigned the, like a P operations with matrices transposed. P transposed. So this is signing of the transposition of matrix. And what Z is equal to? Z equals, what is it? Yeah, it's transposed matrix, symmetric by the main diagonal to the matrix P. And can we find the total? Yes, we can. Like here, total of the matrices P and can we find the inverse matrix to matrix Z? It's a very important procedure for decision of the algebraic equations linear of many dimensions. For 2 dimensions, that's not a big deal, but as for the many-dimensional issues, so the another matrix maybe, what is Z? Z, that we can, oh, sorry, that's not the way to do Z, and the inverse matrix. We can shift and do the upper index -1. Equal, okay. So we find the inverse matrix to matrix Z. This is very important because if we decide the linear the systems of the linear equations more than 2 dimension, maybe 5 equations, maybe 10, 100 equations, etc. We have to have the inverse matrices because the decision is the product of the inverse matrix onto the vector of the right sides of the algebraic equations in the system. The right sides are just only one column, the vector. So when we product the inverse matrix, we can find the decision of the algebraic equation, and so forth. Okay, and we can use here the options in the Mathcad to consider the graph, to do the graphs, to plot the graphs, to do the output like the graph, etc. We can do the text format here, text format. So it's very comfortable, convenient to do the archiving of the, to participate in the archiving in the Word, to transform this into the Word, into the other systems of the documentation and the archiving, as well. So this is how to use the Mathcad computer algebra system. Let me remind that first we have to define the object. The object could be the just magnitude, or could be just a matrix, could be the vector. This is computer algebra system for the operations over the matrices, vectors. And after the definition of the mathematic object, we can do the operations of the object. For example, this is operations augment of the matrices M and S. We have 2 matrices M and S here. That's augment. Augment is just the combination of 2 matrices together. So matrix M first, S second. M first matrix here 2 first columns, S matrix on the right. This is operation augment. Located is matrices here, and functions with the matrices function. We can here find the augment, the operations with the matrices. What is the stack? Stack as well, the combining of 2 matrices, but this one matrix of CST we combine together. So we combine matrix C with matrix S and matrix C. So C is the first 2 rows, S the second 2 rows, and C again the last 2 rows. So the augment and stack about the same, but augment is combining the matrix in the length by the columns, and the stack is combining the matrix of other matrices by adding the rows. As well, we can use the mathematical equations, mathematical operations like square root, etc. For example, we can consider what is mathematics functions, mathematics, yes, square root. We can find what is with square root. Oh, okay, square root of x. With square root, any degree we can find maybe square root of the third degree of 4 plus 4. 4 plus 4 is equals to 2. Yeah, 4 plus 4 is 8. The cubic root of 4 plus 4 is 2 of 8. 2 power 2 to the degree is 8, 4 plus 4. Yeah. So this is the just performance how to use the Mathcad computer algebra system. This is the Mathcad of the Parametric Technology Corporation, the version 9.0.0.0 academic. Perhaps someone can use the Mathcads of the later version or previous version. Not much important the difference for the practical use in the mechanics. So it could be subject to the distribution by the departments of the universities, if the department possesses of the provider or of the developer the right to distribute the program of the Mathcad for students, for teaching, etc. This is for academic version. Okay, so let's come again to the presentation of our lesson. This is again the repeat of the panel of the operators of computer algebra Mathcad. What we can have here is algebra plus minus just a scalar product, the root of definite power, the modulus, factorial, take a percent, etc. As well, the breakdown equations, vectors and matrices. We can do the operations vectors and matrices. We can find the inverse matrix here is very easy to do, especially if we do find the inverse matrices for the many dimensional matrices, like for the decision of the many of the equations or the computer of the systems of the equations. Like in the mechanics, we can decide the matrices for the for the use of the issues with the methods of forces, method of the displacements, the finite element methods, etc. In some issues of other physics, like we only consider the floors in hydromechanics, etc. So this is the table of the panel of the operators of the Mathcad panel. This is example we considered here how to find. First, we have to assign the object. Assigning the object, is it matrix or what? So we have to use to make a choice and to use definite letter, uppercase or lowercase. In lowercase letters, uppercase. After that, we assign. If you assign the matrix object, so we have to dial, or we can use just option of the operators from the panel. It can dial this operator of columns and equality sign. We can just use the keyboard. The keyboard, we dial the buttons of the shift and the columns. We can have this assignment sign, and next use a panel of the operations and to make a choice how many rows and columns and the matrix have to be, etc. Use the panel of the matrices operations over matrices to have the transposed matrix, matrix C, the transposed matrix M here. Another one matrix S, we just assigned that what is S. We can assign matrix as just letters. For example, we assign just with not indication of the numbers, just the letters. A, B, C, D, just 2 lines. And then we can find what is equal, what the macro is equal to. To do that, we have this matrix indicate again the designation of matrix, and just not the assignment sign, but just equality sign to do that. The operations widely used augment is the combining of two matrices together, like the first matrix and the second one. In the last one, the first matrix of 2 columns, the second one of 3 columns here, combined together in this one matrix D by the operation augment with the parameters M and S, names of the matrices here assigned before. The stack, just as well the combining of the matrices C, S, and C. Again, the matrix C we combined with the matrix S. The matrices have to be of the same number of the columns. If we combined it in by the columns, the first we have 2 rows of 3 columns of matrix C. Next, we have 3 rows with 3 columns of matrix S, and on the last we have 2 rows and 3 columns of matrix C again. So this is combining like stack, augment stack. Yeah, we can do the mathematical operations like considered here. Or we can define or assign just the objects a little left from this equation. And next use is just like assigned before. Or we can just dial under the argument of the mathematical action here as well. So very comfortable to use the Mathcad system of the PTC. So what is common actions in the matrix computer algebra system? The action could be submatrix. Submatrix is the selection of matrix S in the matrix M. So we can select matrix X in the bigger matrix M. In the parameters of submatrix operation, the address of initial x1 and I1 and final x2 and details of the source matrix M. So we have source matrix and we have the points of each is the indexes of the by the diagonal of the beginning and the end of the submatrix S of the matrix M. If we'll do that on the next, we will dial S equal to, and after that we will have the matrix which is a product of the submatrix. M with operation plot region, the inclusion of matrix S in the matrix P and obtaining the resulting matrix M in the parameters of the plot region operation, the address of initial cells of the original matrix for insertion of the matrix S. So we put the matrix P into the matrix S. When we can do that, for example, using the finite element method to do the calculation of the mechanical systems by finite element method. We have to have a matrix of the stiffness. The stiffness matrix corresponds to the factors of the system of the equations. It could be very big system, so we have already, if we have the local matrices of stiffnesses, and we have to combine this into the global matrices, matrix of the stiffness. So the global matrix first we just define as a zero matrix, for example, or just diagonal matrix, and after that we do the location of the for each of the finite element in the mechanical system. We define the matrix could be of 6 or so like that dimension for each finite element, and after that we have to locate this into the bigger matrix for the global matrix of the stiffness of the system. The process of finding of the global matrix, if we have the local matrices of stiffnesses of the finite elements, the process is approximately automated. And to do the process, we can use the option path region, the path region command to do the diagonal matrix of the stiffnesses of the definite finite elements to have in the next the automatic process to have the stiffness matrix for all mechanical system. The process, the option augment, the matching the columns of matrices P, S, etc. Stack the matching of rows of the matrices, etc. We did this augment and stack the operations to combine the matrices. The discuss it, and other commands of Mathcad are located on matrices tables. Tap on the functions with vectors matrix panel. And in the computer algebra system Mathcad, we have many comments available and explained very good. Helps to master the skills in using the Mathcad to decide the issues. In our case, the issues of the structural mechanics or other mechanics of the mechanical systems. Besides of the Mathcad, someone can use the Excel program as well. We will consider the use of the Excel program besides of the Mathcad program. We will use the Mathcad program first to decide the issues of the use of the finite element method to find the efforts acting in the mechanical systems. And besides, we will use the Excel system as well. Sometimes Excel system used together with the Mathcad system as a definition of the data for the Mathcad. So to do that, to define the data in the Excel and transpose the data into the Mathcad, transmit the data into the Mathcad, we have to have the files of the data specifying in Excel and the Mathcad file for the decision of the operations over matrices, vectors, and the systems of the equations. Sometimes you have to have these two files together in the same folder. Okay, what is widely used Excel operations to process with matrices and to decide the issues of the mechanics? The command transpose in the Excel. In the Excel, we have first dial the equality sign, and next the command, and we can make a choice of the command in the panel of Excel and the parameter of the command. The transpose matrix, for example, the cosine matrix. One needs to select the placement area in the Excel page, take into account the dimensions of the transposed matrix, and enter a command in the address bar indicating the ranges. The cells of the original matrix and use a combination of keystrokes to execute the command Control-Shift-Enter. So we can transpose the data from Excel to the Mathcad. The command mmult, the multiply matrices in the Excel. For example, to multiply transposed cosine matrix by local stiffness matrix of a finite element bar when obtaining a matrix of discrete model, one needs to select area where the product of matrices is placed, take into account the size of the product, and enter a command in the address of indicating the ranges of cells in the original matrix, observing the sequence of matrices in the product, and use the combination of keystrokes to execute the command Control-Shift-Enter. Yeah, we can do that all in the Excel almost as we can do in the Mathcad. But watching here, anybody understand that the Mathcad is easier to use because just a little bit of formalities we have, the less of formalities we have in the Mathcad. This is more visible than in the Excel. In the Excel, this is very much formal than in the Mathcad. So the command inverse matrix, finding the inverse matrix. For example, the inverse matrix with respect to the stiffness matrix of mechanical system, to execute this command, the Excel one is to use a keystroke Control-Shift-Enter. So yes, we can select in the Excel table these parameters indicated here, and we will have the matrix inverse by use of the command matrix inverse. Questions and comments. The tabs located in the top panel of Mathcad window and options located in these tabs. In the tabs, we have the options like assigning of the object could be a matrix or vector, or we will not assign. In this case, there will be only just a magnitude. Besides the operations over matrices and vectors, the other operations of the matrix, the simple operations, the complex, the dimensions of the used magnitudes can be the physical dimensions, the physical constants, the option of the letters could be Greek letters. We can use not only the Latin letters, but the Greek as well we can have. We have the panel of the format process in the Mathcad, etc. To consider many more details, each can access the Mathcad file and consider in details the set of the option in the panel of the Mathcad window. The use of matrices, tables, step, and options to set matrices to perform operations on matrices. So first we have to select any ledger to make a choice, arbitrary the ledger. Next we have to indicate the assignment. Assignment is or from the operators on the panel of the Mathcad is equal is looks like the columns and the sign of the equality. Columns and sign of the, or we just can have two on the keyboard two buttons together, shift and columns, and we will have the assignment. And after that we have to access the panel of matrices to make a choice of dimension of the matrix. This assignment of the matrices. Use of Math tab to find values of functions and perform the math operations. This likely to say use of the Mathcad to find the values of functions and perform math operations. We have on the panel the option of the matrix of the functions. When we activate this, first we have to make a choice of the name. Oh, it's not the name, just only function. We have find here in the panel, and on the next we can just to follow the indication of the parameters of the operation and indicate correct parameters. The use of document tab to format a Mathcad page. Yeah, we can do the document tab to format a Mathcad page with the use of the style of written text, etc. The common actions in the Mathcad computer algebra system used to perform mathematical operations on matrices when solving systems of algebraic equations, when calculating forces, displacement of deformations in road mechanical systems. It's a very comfortable common actions in the Mathcad because we no need to determine like the indexes of determinant or determine the objects like the inverse matrix. This is automatic, which you just have to assign the matrix, square matrix for determination of the indexes of determinant and object of the inverse matrix. It's easier to do with not the calculations manual. To 4.2.6, the action submatrix, the selection of the matrix from another in the Mathcad computer algebra system is a submatrix operation. We just have to indicate the parameters of the submatrix operation to select a matrix from another. Path region action is the inclusion of the matrix into another and obtaining the resulting matrix in the Mathcad system. The parameters of path region operation. All these operations like submatrix, the same as the path region, are used, and many others are used to simplify the decision of the algebraic equations for the mechanical issues as well. For other issues, but for the mechanical is very comfortable to use for decision of the system of the equations. The human participation only correct assignment of the parameters of the operations. The action augment the combining matrices by columns in the Mathcad system. The parameters of the operation augment. So is the two the 4.2.9. This is a two issues of the combining the matrices together by the columns. The action is augment, and by the lines the action is stack. The read Excel function located on the Mathcad panel on the input-output tab used to transfer tabular data in the matrix form from the Excel program to the Mathcad computer algebra system. Sometimes it's easier to have the data from the Excel to the Mathcad. It's comfortable to dial the data in the Excel, or we can have the data aside in the format of Excel, and we can transform it automatically to the Mathcad. To do that, usually we have to have the Excel file and the Mathcad file together in the same folder. in the Microsoft Office. 4.2.11 commands when working in the Excel program to perform mathematical operation matrices used in calculation of forces, displacement, and deformations in road mechanical system. The common commands is just finding the inverse matrix, for example, just the multiplying of matrices or multiplying the matrix on the vector, etc. The common commands widely used. The transposing of matrix in the Excel. Transposing, yeah, we can do the transposing of matrix from the Excel to the Mathcad. The product of matrices in the Excel program, for example, the product, the transposed cosine matrix by local stiffness matrix of a finite element to obtain the stiffness matrix of discrete model. We can, besides of the Mathcad, we can do this all in the Excel almost. That's all we can do. But in the Excel is less obvious, a little bit more comfortable to use Mathcad due to its obviously. Due to the Mathcad file is very obvious in the presentation of the calculations. But the same almost we can do with the Excel. We have the appropriate options and operators from the Excel, and the question is just only to indicate correct the parameters. Finding the inverse matrix in the Excel. Yes, we can activate the option to find the inverse matrix of maybe very big size, and for the inverse matrix we can this operation we can do correct, specify the parameters. Parameters have to be in the tables of the Excel, and before the use of the Excel operation have to be defined. So these two programs widely used for the decision of the linear equations of the mechanics of the elastic mechanical systems by the methods of the forces, method of displacement, method of the finite elements. Thank you.